Hello my faithful viewers. Today we are going to be going over the list game problem from the Kattis website. As the usual disclaimer, I wouldn't recommend coding in this style for any environment where people are going to be reading your code, as I use not very descriptive variable names and very few comments. Anyway, let's jump right in. So this problem, the main idea is that you need to find the prime factorization of the input number, and then output the number of prime factors. Now, in order to do that, so first off I read in the input here, and then I just call the number of primes function, number of prime factors function on that value, and then output the answer from that function. So the majority of the code for this problem is actually in the number of prime factors function, so we'll go over that now. So first off, I initialize a count variable, so this is going to be the number of prime factors that I'm going to output down here. So then I have a factor to try variable here, and it starts at 2 because 2 is the first prime. And then I just make a shrinking number, which is equal to the 2-factor number, which was my input. Now, the reason I did this is just so I could have the 2-factor number be always constant. I didn't want to be changing that input because I'm going to be using it in this function here. So I needed to make sure that whenever I divide the shrinking number by a prime factor, in order to get to its prime factorization, I didn't want to affect the 2-factor number. So that's why I chose to create the shrinking number here and set it equal to my 2-factor number. So then, while the shrinking number is greater than 1, so that effectively means, whenever I found all the prime factors of shrinking number, which is 2-factor, then that means it'll be 1. The shrinking number will be 1, and so I need to break out of this and return the count down here. But as long as it's greater than 1, I need to keep looking for another factor. So then I have this conditional here, this if. Now the reason I had to do this is because if you go all the way up to the number 2-factor, you actually get a time limit expired on the problem on the Kattis website. So I need to shrink my complexity. And so the way that I did that is I only try factors up to the square root of 2-factor. And the reason this works is because if a number factors the number I'm looking for, to the prime factorization of the number I'm looking for, if it has a factor, then that factor will be either greater than square root or less than square root, but they come in pairs. So if 2 divides it, then that means there's a number greater than the square root of the number that also divides it, but I only need to divide out the smaller one initially. So if I get above the square root, then I know that the number I have left, the shrinking number I have left, after I've gotten above this square root, I know that it's either a prime or it's 1. So I just break here. Otherwise, so if this is 0, so if the shrinking number mod factor to try is 0, so as in the factor to try divides shrinking number, then I iterate the count of my factors and I divide shrinking number by that factor and make it shrinking number. Now, if that's not true, so as in factor to try does not divide shrinking number, then I just need to iterate my factor to try. So after that's all happened, I'll be left with either a number of factors that I have divided shrinking number by, and shrinking number is 1, so that means I found all the numbers of the prime factorization, or I'll have a number which is greater than the square root of 2-factor left as my shrinking number, except I know that that's a prime, because none of the values less than square root of 2-factor divided it. So it has to be a prime. So therefore, there's one more prime. So that's what this if is here. If I'm left with a shrinking number that is not equal to 1, then that means it's a prime, and I did not already count it in my number of factors, and so I need to iterate my count by 1 again. And then I just return the count, because that is my number of factors. Anyway, I hope you guys found this solution instructive. As always, I would recommend doing the solution yourself. Take a day off after watching my solution and then write it up yourself, because really the best way to learn how to code is to do it yourself. I'll leave links in the description of all the libraries and functions that I used. And if you all have any extra suggestions or questions or comments, feel free to leave them in the comment section below. I'd love to hear from you guys. Thanks for watching, friends.